We're going to be talking about ionic bonding, specifically with monatomic ions. And a monatomic ion just means one atom versus multiple atoms, and we'll get into that in a later video. Ionic bonding is between a metal and a nonmetal on the periodic table, and when a metal and a nonmetal combine together, they form what's called an ionic compound. So the metal is referred to as the cation, not cation, cation. So C-A-T-I-O-N, and this takes on a positive charge. So the metal always is a cation that takes on a positive charge. Think cats have paws, takes on positive charge, and they give away valence electrons. So when you take on a positive charge, it's because you're giving away negatives, which makes you more positive. And I'll show you an example of this. The nonmetal is referred to as the anion and takes on a negative charge because it's accepting electrons. So the more electrons you can accept, the more negative charges you're taking on, which makes you negative, referred to as an anion. The metal is always the anion, and the metal is always the cation, and the nonmetal is always the anion. All right, so here's my example. I'm going to take lithium, which is a metal. So on the periodic table, lithium is in the first group on the periodic table called the alkali metals. So your periodic table is already labeled, so when in doubt, if you're trying to figure out if something is a metal or a nonmetal, all of your metals are already labeled. So lithium is an alkali metal, so I know it's going to be the cation and take on a positive charge. And you notice on the top of this grouping, there's a +1 charge there. And so lithium looks like this when you sketch it out as a model. So it has 3 protons, 3 neutrons, and 3 electrons. 2 electrons go in the first ring, 1 electron goes in the second ring or shell, and that 1 electron in the second shell is referred to as the valence electron, or 1VE. Fluorine is going to be, so this is the metal, and this is the nonmetal. So you have a metal plus a nonmetal. Fluorine is going to represent the anion, or nonmetal in this situation. Fluorine is number 9 on the periodic table. So on this periodic table, fluorine is over here. It already has a -1 charge, so I'll show you where that comes from. And as an atom, 9 protons, 9 neutrons, 9 electrons, we place 2 electrons in the first ring, which leaves 7 in the second ring. And what's going to happen, in order to form an ionic compound, lithium is going to give away its valence electron. So this electron right here. It's going to give away its valence electron to fluorine. When it does that, it's going to form an ionic compound. And what that looks like is lithium, because it gave away an electron, now has 3 protons but only 2 electrons, which makes it more positive than it was as the atom, because you had 3 protons and 3 electrons here, so everything canceled out. But as the cation, you only have 2 electrons for every 3 protons, so you end up with an extra +1 charge. You notice how I also redrew lithium cation without that extra ring. So because that electron was given away, it no longer needs that last ring. Fluorine accepted that electron, and when it accepted that electron, which is represented right here, it now has 9 protons, 9 neutrons, but it now is going to have 1 extra electron. So we have 9 protons, but we now have 10 electrons, which gives it an extra negative charge, which is why as the anion, I wrote F-1. So when a metal bonds with a nonmetal, it gives away electrons to take on a positive charge, and the charges are written as superscripts or up above. And fluorine is going to accept electrons to take on a negative charge, again written as a superscript. So you can see lithium, you already have +1 written over that column, and fluorine already has -1 written over that column. So these already tell you what charge the either metal or nonmetal is going to take on. And on your periodic table, if it's a positive charge, +1, +2, +3, well, positive charges are all metals referred to as cations. and then you have -3, -2, -1. All of those are nonmetals referred to as anions that took on negative charges. So that's how you know which one's what. So why do they do this? To complete what's called the octet rule. All elements want to have a full valence shell, and if they don't have a full valence shell, they're unstable. So they trade electrons with each other to gain stability. And when they trade electrons with each other, they form bonds. So what is a full shell anyways? What is a full valence? If you notice on my lithium, I have 2 electrons, and you're thinking, well, octet means 8, so why does this have 2 electrons? That doesn't make sense. Well, we've already established that for electrons, you can only have 2 electrons in the first ring. And so if you have 2 electrons in the first ring, or shell, that means it's full. So even though the number 2 is not an octet, aka 8, you still have a full valence shell with those 2 electrons. So technically, this has completed the octet rule. Same with fluorine. By accepting that 1 electron, it now has 8 valence electrons, which in the second shell, you need 8 valence electrons. So that has also completed the octet rule. So again, just by transferring that 1 electron, both lithium and fluorine have completed the octet rule. I'll give you a couple more examples, but I'm going to write this just as the metal, nonmetal ionic compound formula. So I'm going to take the metal, add it to the nonmetal, and I'm going to form a compound called an ionic compound. So what that looks like using the example that I just did, lithium took on a +1 charge because it gave away 1 electron, which was your metal cation. It bonded with a non-metal anion, in this case it was fluorine, which only needed 1 electron to complete its octet rule. They are going to form, always use an arrow, an ionic compound. The ionic compound they're going to create is lithium fluoride. So, how do I know what compound this is? It depends on the charges. So lithium can only give away 1 valence electron. Fluorine only wants to accept 1 electron to complete its octet rule. The +1 and the -1 cancel out to equal 0. Once that happens, once I cancel out my numbers to equal 0, I know the octet rule has been completed for all the elements involved. That charge goes away, and the elements literally form a compound, so you stick them together. How do you know how to name it? All you do is change the ending of the second element to IDE. So instead of lithium fluorine, which is just listing elements on the periodic table, it's a lithium fluoride, which I know is an ionic compound. Here's another example. Sodium on the periodic table has a +1 charge as well as lithium, which means I know it wants to give away 1 electron. Let's say that it wants to bond with chlorine. Takes on a -1 charge. So as far as the charges go, I know sodium wants to give away 1. I know chlorine wants to accept 1. When that happens, the charge equals 0, which means I know that sodium only needed to give away 1 electron, chlorine only needed to accept 1 electron. And when it forms its ionic compound, it's going to form what's called sodium chloride, which is regular table salt. So instead of sodium chlorine, it's sodium chloride to denote that it's an ionic compound. Well, what if the charges don't cancel out? Because as you saw in your periodic table, you have +1, +2, +3, -3, -2, -1. So let's pick a couple of examples that show how to deal with other charges. So let's pick magnesium. Magnesium's a +2. So as a cation, it is going to give away 2 electrons. What if I wanted to bond that to chlorine? So magnesium can give away 2 electrons. That's what the +2 is telling you. And chlorine only wants 1. So what's going to happen is another chlorine is going to come along. You always have to use the same element. When that happens, magnesium wants to give away 2. Chlorine can only accept 1, so there's going to be 2 chlorines there to accept. So you end up minus 1 is minus 2. So that gets you to 0. So one of the electrons will go to this chlorine, one of the electrons will go to that chlorine, and everything will complete the octet rule. So what does that form? Well, to cancel out these charges, I needed 1 magnesium and 2 chlorines. So this number right here is called a subscript, which represents the ratio of ions, either a cation or an anion, which represents the ratio of ions to complete the octet rule. Another example, well, what if I have something with a +3? So aluminum can give away 3 electrons, so let's try one of those. So aluminum can take on a +3 cation charge by giving away 3 electrons. Well, what if I want to bond that to chlorine? Oh, I'm sorry, back up here. This is called magnesium chloride. Okay, well, as is, aluminum wants to give away 3 electrons, chlorine can only accept 1, so another chlorine will come along, and 1 electron will be given here, 1 electron will be given here, and 1 electron will be given there. So as far as the charges go, aluminum has a +3 charge. There's minus 1, minus 1, minus 1. That's minus 3. That cancels out to 0, so I know the octet rule has been completed. It took 1 aluminum, and I had 3 chlorines. So again, this subscript represents the ratio of ions to complete the octet rule. Well, what if you have something that's bonding to a -3 or a -2? So let's use aluminum again. This is called aluminum, chloride. Okay, so let's bond with aluminum again, and let's say that I would like to combine that with nitrogen. Well, nitrogen as an anion, I know it's an anion because it takes on a negative charge. It's going to take on a -3 charge. Well, +3 and -3 equals 0 right off the bat, so I know +3 and -3 equals 0, so I know that it is going to just look like this. So because the charges cancel out, it took 1 aluminum, which transferred all 3 of its electrons to nitrogen, which is perfect because nitrogen needed 3 electrons. So it took 1 aluminum to transfer all the electrons to 1 nitrogen. So again, this is just a ratio of what it took to cancel the charges or complete the octet rule. And this is called aluminum. Instead of nitrogen, it's nitride. Again, just change the ending of the second element to "ide." Let me give you one more. What if you have a situation where, I'll just use aluminum again, +3, where you have a 3-2. I call this a 3-2 situation. To get my charges to cancel, you have to find what's called the least common multiple. The least common multiple between 3 and 2 is 6. So what I'm going to do to get my charges to cancel is I'm going to make these numbers equal 6. And so I'm going to keep adding on to both sides until I get to 6. So aluminum +3 and +3, that's +6. Add that to -2, -2, -2, that's -6. And it now equals 0. So again, the least common multiple is 6 between 3 and 2. I call that the 3-2 situation. So you just add on to both sides until you cancel your charges. So this aluminum will transfer 2 electrons. And then there's another electron left over, so that one will go here. This aluminum has 3 electrons to give, so 1 will go there, and the other 2 will go there. So this accepts 2, accepts 2, accepts 2. And so all the octet rules have been completed. The compound, it took 2 aluminums and 1, 2, 3 sulfurs. What do you call this? Aluminum And instead of sulfur, sulfide.